So welcome to this week's webinar, Secure Your DMZExtranet with Big Monitoring Fabric 5.5. My name is Sharon Fitzpatrick and I'll be your host for today's webinar. Joining me is Big Switch Network's Head of Product Marketing, Sunit Shahan, and Mustafa Mansour, Technical Marketing, who will be taking us on a deep dive with BMF 5.5. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or you have questions on a particular upcoming webinar topic that you would like our panelists to address, just go to bigswitch.com/webinars and submit a question using the link provided. We also have provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. If you have problems accessing the handouts, please send us a note in the Q&A and we'll be glad to help you. It is my pleasure to introduce our panelists, Sunit and Mustafa. Sunit, it's back to you.
Thank you so much, Sharon. Really appreciate the introduction and glad to be here. Good morning, everyone. We are running a little bit behind schedule given all the technical difficulties we had this morning. So let's just jump into the presentation or the topic for discussion today. This is a follow-on presentation from what we discussed a couple of weeks back. And really quickly to set the agenda, the first 20 minutes or so of the presentation, I'm going to go over the big monitoring fabric, just an overview and the deployment scenarios. Why is it that we have big monitoring fabric and what are the kinds of problems it solves? And then the second half, as we typically do in our presentations, Mustafa is going to give a live demo both of advanced analytics, and we'll try to squeeze in service node demo as well. As Sharon mentioned, please feel free to ask questions. We'll try to address them as we go along, or we will try and address them at the end of the presentation. Now, to level set, let me explain exactly what big monitoring fabric is, and more importantly, what are the challenges in the IT infrastructure space that require us to take a different approach to network monitoring. If you look at the trends in the industry, the networks are becoming bigger, whether they are campus networks, enterprise networks, data center networks. The applications that are running on these networks require more bandwidth. Within the data center, the traffic patterns are changing. It's going from more of a north-south traffic pattern to an east-west traffic pattern. So the total footprint that our administrators, infrastructure administrators have to deal with is expanding. At the same time, the threat vectors are expanding as well. So you need visibility across all of these, vast swaths of the network. Now, when you match those two problems, what becomes very obvious is that as your infrastructure grows and in parallel the tools that you need to monitor grow, in between there, the connectivity, which is a network packet broker infrastructure, that is also linearly growing. So that becomes a really big challenge. How do you really monitor? How do you provide visibility across the complete network in a fashion that's economical? And the first, the first generation troubleshooting monitoring was fairly straightforward. You would just go down to the network and plug in your tool there. But then there was an enhancement or an improvement that was done, which we consider the second generation architecture. And this is what a traditional network packet broker infrastructure would do. And for the time being, this was a good solution till, of course, the network packet brokers themselves become really expensive, and it becomes prohibitive to really implement a pervasive security or a pervasive visibility kind of infrastructure. And this is where big monitoring fabric comes in. So what we've done is if you think of all your network packet broker infrastructure, we've logically chopped that infrastructure and rebuilt the same functionality. But this time around, what we've done is we've built it in a scale-out fashion using bare metal or white box switches that are now programmed from a centralized controller. And there are a whole bunch of benefits that come from doing that. The first, when you disaggregate the hardware from the software, the first obvious one I talked about is the fact that it's a scale-out architecture. You don't have to pick a design that is something for 5 years later simply because you can't really predict how quickly or how massive your network is going to be in 5 years. The way we have solved this problem is you start small. You can start with a single switch, which is the same kind of switches that you use in your production networks, and then you can expand from there. This also gives you the capability to actually monitor everywhere. So something that was economically not feasible in the first generation or the second generation of monitoring infrastructure is now actually feasible, and that's what we're going to discuss today. And then the third piece, which is often overlooked, is when you separate the hardware innovation cycles from the software innovation cycles, you're able to not only get the economies of scale and the benefit that brings to your CapEx aspects, you're also getting much faster innovation in terms of new features and functionality that gets introduced. And all of that put together makes this solution really, really economical. So today what we're going to do is talk about the, what are the enhancements that we've done in our release 5.5. And I'm going to talk about that in the next section. But first, let me go into a little bit of, I showed you what the problem is, how we are trying to address that problem. Let me talk about 2 or 3 different deployment scenarios in which people are actually using this particular product. The first one is an example of pervasive monitoring requirement, where the key was for a large, tier 1 US financial services institution. What they were looking for was an ability to on demand bring traffic from any part of their data center to a particular set of tools. And the way they did it was, if you look at the slide that I'm sharing on the screen here, there are 120 racks with dual top of rack setup. And the way they basically decided to monitor all of their east-west traffic was to bring 40 gig span links from each of the top of rack switch into what we consider the filter switches. So those are the switches that are sitting, those blue shaded switches on this screen that are sitting on top of the 120 racks that are shown here. From there, the traffic actually, the monitored traffic, this is out of band deployment, so you're making a copy of the production traffic. The traffic gets sent towards the core switches. Those are the switches in the center of this diagram, and then the traffic gets filtered, aggregated, replicated, depending upon however your policies want to shape that traffic. The traffic gets sent over to the tools. Again, the key here is that all of this infrastructure, everything that is being shown in the shaded blue area is managed from a single HA pair of controllers. So there's no more box by box kind of monitoring. When you try to figure out what a particular compromised host is doing or the kind of traffic pattern that is being generated, you're not trying to log into n different boxes and trying to figure that out. All of that information is available at your fingertips through the BMF or the Big Monitoring Fabric controller. So that's the first the use case or the deployment scenario. Moving on to the next slide is another, using the same Big Monitoring Fabric infrastructure. What you can do is deploy it in an inline in-band mode in a DMZ. So this is a Fortune 50 oil and gas company. What they wanted to do was, across tens of their global data centers, what they wanted to do was have a mechanism where there is a clear separation of what the security team is doing and the tools are doing in the DMZ and what the network team is doing. So they were looking for features and functionality, things like tool chaining in the DMZ. So from the same Big Monitoring Fabric controller, using the same production switches that I mentioned earlier, rather than deploying it in an out-of-band mode where you're replicating production traffic and bringing it back to the tools. This is a different use case where you actually look at all the in-band or inline traffic going back and forth between your data center or network and the internet, and you chain the tools that the traffic has to go through. And over here, what we've done is we've implemented very nice functionality in terms of tool chaining, tool health checks, what happens when a particular tool goes down, all kinds of HA configuration, fail open, fail close kind of functionality. And we've done a separate webinar on this topic as well. So that's the second deployment mode. But again, everything is managed from a centralized location. So you're not logging box by box. And finally, the third use case is some of our customers and users, they've had these scenarios where remote locations are smaller and they are not able to actually monitor those remote locations. Simply because you can't replicate all of your tools and the NPV infrastructure there. So what we've implemented is an ability to remotely monitor the traffic, bring back the relevant traffic from remote locations to a centralized set of tools. So those are the kinds of, if you look at your security infrastructure holistically, what our customers and users are looking for is this ability to do pervasive security, pervasive visibility without the challenges that are associated with box-by-box management of an infrastructure. And when you're able to do out-of-band monitoring, when you're able to do your in-band or inline security at the DMZ level, as well as your remote small location monitoring from a single pane of glass, that's the kind of functionality that our users have been looking for, and that's the kind of functionality that Big Monitoring Fabric brings. So moving on, in the interest of time, let me talk a little bit about what are the features and functionality that we've added in our latest release. Going back to the architecture slide, just to level set the different things that comprise Big Monitoring Fabric solution. On this screen, you have on the left a production network, and that's where this is your existing network. You could have, any vendor providing that network. From our perspective, there are optical taps and span ports that bring the traffic back into a set of filter switches. That's the fabric sitting in the middle, and on the right-hand side you have the centralized tool farm. This is where your tools, the optimized utilization of tools is happening. Now with release 5.5, if you look at the three key components that form the Big Monitoring Fabric architecture, we've made enhancements at the controller layer, we've made enhancements at the switch infrastructure fabric layer itself, and finally at the bottom layer where the advanced services are being provided. So as I mentioned earlier, with Big Monitoring Fabric controller, it is a simple programmable interface. You can actually have your own programs that triggered events that can program policies, but we've had that for a pretty long time. What we've also had is this capability for advanced analytics and telemetry. With release 5.5, what we've done is we've taken it to the next level. So in addition to providing you snapshots at a single point of time in terms of what are the hosts, what are the DHCP requests coming into the in your production network, we are now collecting a lot of that information into this advanced analytics and telemetry node. Think of it as it is actually deployed as a virtual machine on the same controller appliance or a separate appliance, but this is collecting a lot of information, sniffing a lot of information that is relevant when you're trying to figure out a needle in a haystack. When you're trying to figure out what happened in a time series fashion, we are collecting all of that information, and using Elasticsearch as the base for this infrastructure, we can give you very nice insights in terms of analytics on your production network. So Mustafa is going to give us a demo of this functionality shortly. So I won't. It's much nicer to look at than look at the slides themselves. So I'll not go into too much detail there and let Mustafa talk about it. Now moving down in terms of the components of the solution, the second key component, as I discussed earlier, has to do with the switches themselves. Now, we've always supported 1 gig, 10 gig, 40 gig switches. The architecture, as I mentioned earlier, is a scale-out architecture. It's very fungible in the sense that you can start with a single switch if you have a very small footprint to manage, and then you can expand it to thousands of or tens of thousands of points in your network that you would want to tap and bring traffic back from. The other benefit, of course, here is that these are the same switches, the same Broadcom ASIC based architecture that you're using in your production network. So very high density top of the line switches are being used here. With release 5.5, we've taken the next step, and now we are supporting 100 gig switches as well. So as I'm showing on this screen, for our 100 gig switch portfolio, we've added Dell Z9100 as well as Acton 7712 switches. So effectively, you can now, depending upon the oversubscription ratios that you want in your fabric, depending upon the kind of tools that you want to filter your traffic into, you have an option of going all the way from 1 gig to 100 gig on a single port. So that is new in our latest release 5.5. And moving down along the same dimension, what we have is as I mentioned earlier, 80% or even more percentage of the functionality that any network packet broker actually provides has to do with filtering, aggregation, replication of the traffic. And that is something that the fabric in the middle is already providing. But then there are some advanced packet functions. Think of those as your, deep packet inspection kind of functions. And for those, what we've done is we are now introducing in our latest release 5.5, we are introducing an Intel DPDK-based appliance for initially 3 different services. So packet deduplication, packet slicing, as well as RegEx or pattern matching. So going forward, what we've done is, just as we took the notion of using economical, bare metal or white box switches for the monitoring fabric, we are using for advanced packet filtering and advanced packet processing functions, we are using x86-based appliances. Same philosophy, decoupling the hardware innovation cycles from the software innovation cycles. And we are starting with the 3 services that we are showcasing here, and Mustafa is actually going to give us a demo, or we're going to try and fit in the demo in the time that we have, at least one of them. So we will show you how easy it is to actually run a deduplication or a packet slicing function. And with that, Mustafa, let me hand it over to you, and then we'll go into the demo.
Thanks, Sunit. So now we're going to go to the demo part, which is, by the way, my favorite part of the webinar. You get to see the product in action. You see how easy it is to configure our BMF fabric, and what does SDN actually brings to you. Okay, my name is Mustafa Mansour. I'm a senior technical marketing engineer here in Big Switch. I'm responsible for the BMF solution, the big monitoring fabric product that we're going to show you today. I will start with the analytics demo. Analytics is one of the features, the unique features that we have in our product. Other competitors don't have anything that comes close to it. We actually started the analytics a couple of releases back, I think more than a year and a half ago. We started with trackers, and then we added the flow analysis, and then we added fabric analytics. So actually our analytics feature is very rich, and you're going to see a lot of it today. What you see here on the screen is the GUI, the UI for the SDN controller that we have in Big Switch. If you go to the host tracker, you will see this page. This page is basically a database, live database, that has every IP node that you have in your network. We sniff R packets, DNS packets, DHCP packets that are coming from our tap and span, feeding the filter ports. If you're not familiar with the terminology, filter ports meaning the ports on the switches that are facing tap and span on your production network. So we sniff all these packets, and then we build a database based on the IP addresses, MAC addresses, host names, vendor types, VLAN numbers. We put all this information together using the centralized brain, which is the SDN controller here. So we correlate all the traffic that's coming from different switches, different ports, and we build a live real-time database with all the IP nodes that you have in your network. This information is very useful to our customers in different ways. For example, if you want to troubleshoot a host that's in your network, someone is creating a ticket saying, hey, I cannot access website X or server X. How do you troubleshoot that? So in the past, you used to log into his computer in order to see what he's doing, but with the host tracker, it can become much easier. I can filter based on a host name, IP address, MAC address, a vendor type, or a VLAN number, and I can start right away a policy from that specific host and start sniffing the packets or doing a packet capture on our controller and open Wireshark and analyzing his data. So here, for example, I will start looking at my machine. I have a MacBook that I'm using to do the webinar. I will put Mustafa here in the filter. This is my host name, and it will show Mustafa MacBook Pro. And it will also show which interfaces it came from in the fabric. I can select my host, right-click, and say Start a Policy. And once you do that, you will see the policy wizard. You can customize it, or you can leave the default populated template that we have. You can say that I want to capture this packet locally on the controller and open a Wireshark, an embedded Wireshark that we have, and start looking at the traffic. You can forward to another tool. You can do whatever you want to do with it. But that's easy. That's how easy it is to create a policy from a host and then click submit. You're done. You can search instead of the host name by IP address by other fields that you see here. For example, let's say I'm interested in all the iPhones that are running on my network, or all the Windows XP, or anything that you see in the vendors column. Or in this case, I'm looking for iPhones. So maybe all the iPhones, I want to send them to a specific tool, all the traffic that comes from these iPhones. So I can select all of them and create a policy, similar to what I did for my machine, for Mustafa machine. That's one application, and you can only get it when you have a full view of all the traffic that's coming from your network, feeding the BMF, and we correlate this traffic together regardless of which port or which switch they are coming from. Another thing you can do here, you can look at the last seen column. The last seen column is actually very nice to have. It will show you who was on your network, when did they join by looking at the first scene, and when was the last activity that they had on the network, the last ARP message or the last DNS or DHCP message they had. So let's say you're an IT guy and you give VMs to your employees based on tickets or requests that they have. Now, this employee hasn't used his VM for more than 3 months or 6 months. Is it time to take it back and free up some resources? Instead of using this compute and memory and IP addresses that you hand out, maybe when you look at the last scene, if something exceeds 3 months, you get notified and you ping the host or the IP address that belongs to this VM and ask him to decommission it and release it back to you. So that's another application that you can use using Host Tracker. On top of it, you can see the VMs usage, whether they're containers, VMs, physical host, or anything, and you see when they were used. Another thing that you can do here is looking at the IP addresses, and you can see that each IP address has a MAC address that corresponds to it. But what happens when the same IP address has multiple MAC addresses? Is there someone doing layer 2 spoofing, man in the middle kind of attack? Or one MAC has multiple IP addresses, so someone is doing layer 3 spoofing? Or maybe just you have multiple IP addresses because someone misconfigured his IP address on the network card. It actually happens to me once where I configured in my subnet a static IP address to a VM, and another colleague of mine did the exact same thing with the same IP address on his VM. So actually we saw right away that there are 2 IP addresses showing up, or 1 IP address showing up with 2 MAC addresses. It's just a misconfiguration that we both did the static configuration for the IP addresses. Of course, this means that IP connectivity will be broken because you have 2 machines with the same IP address. So there are multiple things that you can do on top of this framework or this information that we provide. And remember, this is like real time for what's happening right now. Whether it's an IP camera, a printer with an IP address, a VM, container, a physical host, a server, anything that talks IP will be here in this database. So after we had the host tracker, the release after that, we added more trackers. We added DNS and DHCP trackers. So DNS, for example, will show you all the DNS servers that you have in your system. Some of the servers may be legitimate servers. They actually the servers you installed and configured for your employees, or some of them may be rogue DNS or DHCP servers, or they may be just misconfiguration from the user part. So let's say I create a VM. I don't know the DNS server of the company, but I will take the shortcut and type 8888. It's a public IP address for the Google DNS server. So you may be okay with that, or you may not. It may be a problem for your security policy. You may say, no, I don't want employees to misconfigure DNS and put a static DNS server that doesn't belong to the company. I want all the traffic to be queried to be sent to my DNS server before it goes out. So it's good to know who's doing what. And this DNS tracker will show you real-time information about all the DNS servers that are configured and which subnets or IP addresses they are serving. So it's good to find rogue DNS servers. It's good to find misconfigured DNS servers. And same for DHCP tracker, same concept, we have all the DHCP servers. So we built this databases, host tracker, DNS tracker, and DHCP trackers, and they are real time. Customers love it, but they came and asked for more information. They don't want just real time. They want history. They want time series. They want to know what happened last week at 12 p.m. Who was on my network? What did they do? I had an attack, or I had an audit, and I want to know machine X did what on Tuesday, March 2nd. How do I find this information? How can I go beyond the real time and give me a trend or a historical view? So we actually enhanced the trackers, and we went to advanced trackers, or trackers with a historical view. So the same stuff that you saw with the controller, where I talked about the host tracker, DHCP tracker, and DNS tracker, now we have them as a VM running advanced analytics, getting the traffic from the controller, and we show that over time. So here I go to the demo host tracker, and you see that we get the exact same information, same table, but we get it over time. And you can filter based on what you're looking for. You can say I'm only interested in the last hour, or I'm interested in the last 30 days, or I will make a custom date and choose the exact dates I'm interested in. So you can know who was on your network at what time and what did they do. And we went beyond the 3 trackers, DHCP and DNS and host tracker, and we added more trackers, like ICMP, for example. Every single ping request that someone did on your network, whether it's ICMP ping or ICMP echo request, echo reply, or message too big, or MTU error message, anything that happens that relates to ICMP, regardless of which switch and which interface it came from, it will be mentioned here. And you can click on any of these fields, and you can filter based on a message type, or an IP address, or a port number, or something like that. You can customize any of these fields. You can click here on the configure and change it from a pie chart to a bar chart to a line chart, or whatever your chart you're looking for. So here is another view for the DNS tracker. So you have seen it on the controller. It was real time, but here's over time. You can filter based on a specific IP address. So you just click on the filter button and put the IP address or the host name you're looking for, and you can see what queries a specific host did. So if I'm looking for my machine, and I can go back yesterday, for example, and I can see from 6 to 6:30 what are the DNS queries I did. And the DNS queries means which websites I went to. So you can know what kind of activity this person did. We have something called host view, and host view is basically a summary view that collects all the other views together. So it puts here like S-flow information that was generated from a specific host, or ICMP messages, or DNS messages, or DHCP messages, or ARP messages. We put all this together from a single view. So you can filter based on a specific host and know everything that this host did. Another view we have is the S-flow. So trackers is one thing, but in addition to trackers, we added flow analysis. So our switches by default will start generating S-flow records. And in the controller here, as you see, we have an S-flow collector that's built inside our BMF solution. So it's integrated in the solution. And this S-flow collector will give you like top talkers. Who was on my network, who's using the most bandwidth, whether it's by port, or a flow, or a source IP address, destination IP address, or by a VLAN number, or a protocol type. And if you want something, just click on it and it will be filtered. Or you can even filter based on the table here. We can also put things like geographical information. The IP addresses, where did they get originated from, and which places they went to. So you can see if someone is going to some place in Africa or South America, and you know you don't have customers there, or you don't have web servers hosted there, then it can be suspicious, and you can start looking at their traffic to see what they are doing over there. So this is S-flow. It's great for network analysis, to give you an understanding of what's happening on your network, and then you can drill down or filter more based on your specific needs. So trackers is one thing, flow analysis and network analysis is another thing, but here is the third thing that I want to show you with you, and this is fabric analytics. So far we have been talking about how to give you information about the production network, because we are tapping and spanning the traffic that's coming from the production network. But let's say I'm interested in traffic that's coming from my fabric itself. Like I'm interested in the events that happened in my fabric. Which interfaces went up or down? Is there any link or a node that changes status? Did someone remove a policy that I created? And when did this happen? Stuff like that. So we are looking for analytics on our fabric itself, not on the production network. I also may be interested in statistics about the interfaces that are in a certain policy. If I create a policy, I want to see the policy stats, and I want to see the interface stats that belong to this policy. So how do I do that? So you have multiple dashboards here. I can't go over all of them today. We don't have enough time. But here's like an example of BMF events, or BMF policy stats events, or interface stats by itself. So if you go to the BMF events, I see that I have some events that relates to port status change. I have some ports that got changed from up to down. I have some new policies that got installed. I have some policies that got removed, and at what time. And if you scroll down, you can see actually some of this information here, like this policy or this interface happened on which switch, and what's the interface name and what happened to it. By the way, this happens in addition to SNMP and MIBs, so it's not a replacement. It's just another way of giving this information. It's a more visual way that helps customers understanding what's going on in their fabric. This is another example of policy stats and interface stats, where you see all the filter interfaces, delivery interfaces, switches that I have in my network, core interfaces, and the policy stats. If you click on any of them, then you will start going deeper inside which interfaces are using this policy and how much bandwidth each interface consumes for that specific policy. That's it for the analytics part.
I think
do we have time for?
Let's do a quick service note just to showcase that. I know we have a couple of videos already posted on our website as far as the service node functionality is concerned. Might be a good idea to just show the packet deduplication piece.
So as some of you may be aware, we have a service node, a BMF service node, and it can do advanced features like dedupe, packet deduplication, packet slicing, or pattern matching using regular expressions. So I will start with one of the features, and then you can see videos that we have on our websites for the demos on the other features. Let me start with deduplication. Deduplication is basically finding duplicated packets that happen in your production network, maybe because you are tapping in multiple places, so you're getting the same packet multiple times. These packets can be identical packets, or they can be a little different, depending on whether you're going through a layer 3 switch like a router, and this router may be changing some fields like MAC addresses, VLAN ID, or just changing the TTL value. So it's the same packet, but it may have different fields. We have the ability to actually find out whether this packet is duplicated or not. And in the configuration part, we have two modes, full mode and routed mode. Full mode means we can look at identical packets only. Routed mode means we can look at duplicated packets even if they have different fields. The demo I'm going to show you here is very simple. I have two hosts. One is the client, one is the server. I will do a ping between the client to the server. I have two taps, or actually two spans, and I will get the packet twice. But I will insert a BMF service node to the fabric. The service node and the fabric are managed from a single pane of glass, which is the BMF controller. The service node is more like a plug and play. Once you physically connect it to the BMF fabric, the controller will discover it automatically and will do path calculation to know what's the shortest path to reach that service node. So once you insert your BMF service node, attach it to the policy of the one you created, traffic will be deduplicated, and we are going to remove the extra copies of this packet, and then we'll send the traffic to Wireshark. So I will do a ping without the service node, and then we'll see what we are going to receive on the Wireshark. Then I will add the service node and do another ping. So this is my my terminal. I have a client over here. I will ping the server 5 times. So this is count 5, and this is the server IP address. On the right side, you see Wireshark. So if I do that, I send 5 pings, and on the right side, I see 10 packets that are being received. If you scroll down, you'll see that the sequence number was repeated twice for each packet, because each packet has been tapped twice. If I go to the policy, I have a policy here called dedupe, and this policy basically takes the traffic from the taps and send it to the Wireshark. To add a service node, extremely simple. I will go to the Manage tab, Manage Service tab, and I will click on the plus sign to add a service node. This is like a service node profile. We have multiple features, so we'll give it a name, and then we'll choose which features we want to apply on the service node. One of the good things about the service node, it's extremely flexible. It can have multiple features happening all at once on the same appliance. So here I will say dedupe service, and the service node will come with multiple ports. So you have to choose which port you want to apply the service on. I will go here and select this interface. It detects that the service node is configured, and then it will ask you for the action. So as I mentioned, we have multiple features, pattern matching, slicing, dedupe, even JTP load balancing. So I will go with the dedupe, and I will choose routed packet. I click save, and that's it. You are done with the service node configuration. The only step missing is to link the service node to the policy that we had already. So I'll go back to the policies. I'll go to the dedupe, and under manage service, I will add the dedupe service node that I just configured. We have something here called optional, which means that if the service node is available, send the traffic to the service node. If it's not available, you can say whether you want to bring down the policy or you want to bypass service node. So you can even do fail open, fail close for the service node if needed. And if I go back to my Wireshark, let me clear the screen and do another ping. Oh, actually I didn't click submit. So I will save here. Now I saved the dedupe policy. So let me go back to Wireshark and click and do another ping. So this time if I ping, I'm pinging 5 times, and I'm getting 5 packets on the screen. That's how simple it is to configure dedupe and attach it to one of our policies. And as you saw, everything happens from the same screen, from the same GUI. That's the SDN controller, whether it's CLI, GUI, or REST API configured. That's it for the demo. Back to you, Sunit.
Perfect. Thank you so much, Mustafa. In the interest of time, let's go to the last slide. There are a few questions that came in. We'll try to address a couple of them here, and the rest of them we'll take them offline and send responses to those individually. The first one has to do with, it's a very important question. It has to do with can you cover SFlow and NetFlow support? The current fabric itself actually supports SFlow. That's the capability that the Broadcom ASICs actually provide. As far as NetFlow is concerned, that's another use case or requirement that a number of our users and customers have asked for. I think the challenge there, of course, is you don't want to use your production network nodes, whether they're switches or routers, and overload them with NetFlow functionality. And one of the things that we are looking at is how can we bring the same capability that we have with SFlow, but using the service node architecture. But again, that is not something that we support today, something that we are very aware of, and will be as a team here at BigSwitch, we're working on that. The second part is, the second question here has to do with, if you're an existing big switch customer, you already have Big Monitoring Fabric deployed, do you have to buy analytics node as a separate additional product? And that's definitely not the case. Everything that we provide comes as a package. So when you upgrade from, say, version 5.0 to 5.5, you have the capability and the ability to get the latest functionality as far as analytics and telemetry is concerned. It does get deployed as a separate virtual machine simply because we want to make sure that the information, or it is sandboxed. It has its own set of resources, hard drives and CPU resources. It doesn't have to be on the same controller node. We support both architectures where you can deploy it either on the same Big Monitoring Fabric controller node or a separate node. But again, to answer the question, it comes. This is the nice thing as far as new innovation is concerned. As we release new features and functionality, that become available to you existing users as well. With that, I think we've run out of time here. We're already a couple of minutes over. Sharon, let me hand it over to you, and we'll conclude the presentation from our end.
Thank you so much, Sunita Mustafa, for a great presentation. The deep dive into BMF 5.5 was very informative. So if anyone has any questions or comments to share, you can always reach us offline at info@bigswitch.com. So we'll make it easy for you to get started with Big Switch Solutions, offering 3 choices. BSN Labs, which is where you can experience Big Switch bare metal SDN solutions firsthand from the comfort of your PC. We believe there's no better way to learn about a product or technology than to take it for a test drive. So if you would like to have a free online real-time access to our SDN Fabric products, please visit labs.bigswitch.com or download the handout, which will give you additional details. The Community Edition, you can now evaluate Big Switch Network's SDN solutions on your network at no cost. We're offering new Community Editions for both of our production-grade SDN Fabric solutions, Big Cloud Fabric and Big Monitoring Fabric. You'll also find details in that handout on your dashboard. And last but certainly not least, we've launched BMF and BCF starter kits, starting at a list price of $29,000 and $39,000 respectively. These kits include the switching hardware, software, supporting cables that make it easy for you to implement your very first SDN-style data center pod. If you have any questions or need more information on that, please make sure that you look at the detailed brochure online. We have some upcoming events. Let me share them with you. All of our past webinars, including this one, will be posted online, and you can get to those by clicking one of the green buttons on the homepage. Mark your calendars for our partner webinar with VMware on Wednesday, February 4th, VMware Integrated OpenStack plus NSX plus Big Cloud Fabric, delivering simplified visibility and orchestration. And on March 9th, we'll do another deep dive. This time you'll learn more about Big Cloud Fabric 3.5. Watch your emails for registration details or visit our webinars page on our website. Well, that concludes today's presentation, but if something we discussed piqued your interest or you'd like to know more, just head on over to our website, bigswitch.com. Thank you and have a great rest of your day.